So this problem is dealing with spherical mirrors, and basically problem 11 is asking us to repeat a situation that is described in 10. And normally you can do mirror calculations and lens calculations by plugging in numbers into formulas. But you can also do it by drawing an actual diagram to scale. Now, since it's kind of hard for me to draw a diagram to scale on an iPad, I went ahead and drew this diagram to scale on my computer and worked it out. And I'll walk you through how to solve the problem, and I'll give you the answers that I got. But in order to really understand how to do this type of problem, you should get your own sheet of paper and ruler out to help you understand these concepts. And I actually use graph paper, which is helpful because once you're drawing all these sorts of lines, it's kind of confusing as to what's going where. So, to begin, it says that you have a focal length of 20 centimeters, and the focal length is the point the length from the focal point to the mirror. You have an object distance of 12 centimeters and an object height of 2 centimeters. Now, when you draw this out to scale, if you're going to do a focal length of 20 centimeters, you might as well try to do this on a sheet of poster board. Now, obviously, the more exact you are with your measurements, the closer your answer is going to be. But what I went ahead and did was I divided all of these numbers by 4. So that gave me a new focal length of 5 centimeters, an object distance of 3 centimeters, and an object height of 1/2 centimeter. Now, when you divide by 4, you have to remember in the end to multiply your answers by 4. So now we're going to go ahead and draw the mirror. So we're drawing a concave mirror here. Now, although it's a concave mirror, we're going to want to make it as straight as possible because we're going to have rays intersecting this mirror. So not completely perfect, but I'm just going to draw the straightest line that I can to show that the rays are all hitting the mirror equally. Now it's kind of hard because I'm not a great artist. So the next thing that I'm going to do, I'm going to draw the horizontal surface. Okay, so I'm going to go ahead and identify F over here at about 5 centimeters distance from the mirror. I'm going to draw the object about 3 centimeters from the mirror with an object height of about 1/2 centimeter. Not perfect. I'm sorry. I tried. So we're going to be drawing a couple different types of rays. Now the first ray that we're going to draw is going to be a ray that strikes the mirror parallel to the horizontal and then is reflected back through the focal point. So we'll go ahead and draw this ray as close as we can. So it hits the mirror. I know it's not exactly hitting the mirror. It's hitting that parallel line, but it's the best I can do under the circumstances. So it goes to horizontal, reflects off the mirror, back through the focal point. Next, we're going to have a ray that passes through the focal point and the image and then reflects back to the horizontal. So, let me just draw some lines here so we can see what's going on. So this second ray is going to start at the focal point, go through the object, hit the mirror, and then be reflected back along the horizontal. So in order to avoid confusion, I'm going to start this line at the object. It's going to hit the mirror, whoops, and reflect approximately parallel to the horizontal surface. So the idea here is that the image is located in the area between where the two lines intersect and the horizontal surface. So right now, these rays are definitely not intersecting. So what we have to do is we have to extend the rays beyond the mirror, which means that we're going to be getting a virtual image. So this first ray, we extend it back, and then sure enough, this horizontal ray, we extend. Sorry for the rough depiction. And then voila, there's our image, the point where the lines intersect to the horizontal. So, because you were so precise in measuring out the focal length of 5 centimeters and the object length of 3 centimeters and the object height of 0.5 centimeters, everything that comes up on this side should be to scale. So, when I took my ruler and measured everything out, I measured an object height of 1.2 centimeters. Now, is 1.2 centimeters our answer? No. Since we divided everything by 4 to make our drawing more manageable to handle, we must multiply everything by 4. So the object height is 4.8 centimeters. I'm sorry, the image height. Height of the image. So that's 4.8 centimeters. And the location of the image. So the location of the image is going to be this area to the right of the mirror. Now I measured it from my handy dandy little vertical line since I can't draw a really straight, almost straight concave mirror. It's hard. So that distance that I got was 7 centimeters behind the mirror. And 7 centimeters, of course, is not going to be the answer since we divided by 4. We must multiply by 4. So our answer is 28 centimeters. So the location of the image is going to be 28 centimeters behind the mirror. And the height is 4.8 centimeters.